Yes, welcome back to the session. In this video, I am going to discuss about force due to semicircular rod. Okay, so look at this diagram here. We have a semicircular rod having a positive charge. So this rod is completely filled with the positive charge. Okay, the charge symbol I am taking Q, and its radius will be R. So this will be the center. Now we are going to calculate force due to semicircular thin rod, right? Let's say for example, I'm taking a charge or test charge which is located exactly at the center. So the test charge, let us assume Q naught. 1 second. Yes, the test charge I'm taking Q naught, which is located at the center. Now we are going to calculate electric force, correct or not? So for that, I'm just taking a small length element. Let us assume this will be the length element dr, so in which the charge will be dq. Okay, now what I'm doing here, I'm just connecting a line from center of the semicircular ring to that length element. Yes, it makes an angle d theta. Okay, I told you already the radius of the semicircular ring will be capital R. Okay, now first of all we are going to calculate linear charge density, because basically the rod is in the form of uniform straight rod only, correct or not, which is bent in the form of semicircular shape. So the linear charge density for this semicircular ring is lambda is equal to dq by the radius into angle becomes d theta. So from this, dq is equal to lambda r into d theta. Please remember this one. Okay, so this is the small elemental charge. Okay, now what I'm going to do here, this elemental charge I'm going to substitute in Coulombic force, because we are going to calculate force, right? So I'm going to use Coulombic force formula. We know that Coulombic force formula is F is equal to 1 by 4 pi epsilon naught into the initial test charge will be Q naught and the other charge will be dq by r square, correct or not? Yes. Now dq value already we know how much, lambda or d theta, right? So that value I'm going to substitute here. F is equal to 1 by 4 pi epsilon naught into Q naught lambda or d theta by r square. Okay, so here numerator r and denominator 1 are cut. Therefore, the Coulombic force F is equal to 1 by 4 pi epsilon naught into Q naught lambda d theta by r. So this is the expression we got. Now whenever a small angle will be present, so we are going to resolve into two components. Okay, so what I'm going to do here, I'm just extending this line in downward direction, so it makes an angle theta, correct or not? So whenever it makes an angle theta, so horizontal component will be this one. So we can write it as fx is equal to f cos theta. If we know the horizontal component means easily we can calculate vertical component. So vertical component will be fy is equal to f into sin theta. That means the force we are going to resolve into two components. One is force along x-axis and the other one is force along y-axis. Let us see what I am going to do here. First of all, I am going to take horizontal component. So for horizontal component means already we got fx is equal to f cos theta. Am I right? So let us assume this is equation number 1 and this is equation number 2. Now force formula already we know. Directly you can substitute in equation 2. So I am writing here substitute 1 in 2. Therefore fx is equal to 1 by 4 pi epsilon naught into q naught lambda d theta by r into cos theta. Okay, so after writing this step, I'm going to integrate this cos theta. Let's see, fx is equal to 1 by 4 pi epsilon naught into q naught lambda by r into integral over cos theta into d theta. Okay, so which is varying from the initial least angle will be 0 and semicircular shape now, so the final angle will be pi. As we know that integral cos theta becomes sin theta, right? Yes. So the next step, let's see, force along x-axis which is equal to 1 by 4 pi epsilon naught into q naught lambda by r into sin theta, which is varying from 0 to pi. So this expression we can write like this, 1 by 4 pi epsilon naught into q naught lambda by r into, first I am going to substitute pi, so sin pi minus sin 0. Okay, as we know that sin pi value is 0 and sin 0 value also 0, so therefore force along x-axis will be this much into 0, so therefore along x-axis the force component will be 0. Okay, I hope you understand. Now one more component is there. What is that? Vertical component. What is the vertical component here? Fy is equal to f sin theta, right? Yes. Now I'm going to calculate vertical component. Let's see. So we know that vertical component, we can write it as Fy is equal to f sin theta. Am I right? So f formula already we know. What is the f value here? F formula is this much. So I'm going to substitute there. Let's see. So we can write it as f formula is 1 by 4 pi epsilon naught into q naught lambda by, one second, q naught lambda d theta by r, d theta by r into this sin theta. Okay, so this will be the force along y-axis. The same thing I'm going to do here. I'm going to integrate the sine component. Integrate the above expression. Let's see. Fy is equal to 1 by 4 pi epsilon naught into q naught lambda by r into integral sine theta into this d theta. So as it is, the initial angle will be 0, the final angle will be pi. Okay, so therefore we can write it as 1 by 4 pi epsilon naught into q naught lambda by r into integral sine theta becomes minus cos theta, which is varying from 0 to pi. Now I'm going to substitute these boundaries. Let's see, 1 by 4 pi epsilon naught into q naught lambda by r into minus cos pi minus cos 0. Okay, so which is equal to 1 by 4 pi epsilon naught into q naught lambda by r into minus 1 minus 1, so that becomes 2. Why I'm taking? Cos pi value is minus 1, right? Into that is also minus 1, so minus of minus becomes plus. So therefore 2 ones are 2 twos are, so we can write it as q naught lambda by 2 pi epsilon naught into r. So this is the force along y-axis. Still continuation is there. If you want electric field, that is also easily we can calculate. Let's see. As we know that electric field basic formula, force by charge, right? The charge I am taking here, sorry, uh, the charge I'm taking here, it's not working. Enough. So the electric field we'll discuss later. Okay. I hope you understand. Thank you. Thank you so much.